Logical evolution for positive integer exponents. Now you know that multiplication is shortcut for addition, and all actions in math are connected. This is why exponential form is a shortcut for multiplication if factors are the same. 3 squared equals 9, or 3 times 3 is 9. Now we are going to expand our knowledge about exponents because we are going to talk about a situation where negative numbers are involved. And after that, we will learn how to use a calculator.
Positive integer exponents. Let's look into product positive 2 times positive 2 times positive 2 times positive 2 times positive 2. Positive 2 we would call factors, and instead of showing this long chain we can use shortcut, and this shortcut we would call exponential form. 2 is a base. Base tells us what number we are going to multiply by itself. And 5 we would call exponent or power. Exponent tells how many times we are going to multiply this number by itself. And we can read this expression as positive 2 or just 2 to the 5th power. If we have next example, we can read it as 4 to the 2nd power or 4 square, because it represents area of square with a side 4 units long. In this example, base was positive 2 or just 2, and because we are learning about positive and negative numbers, so now we are going to develop next example where negative 2 is a factor. So how to show exponential form? It's supposed to be negative 2 within parentheses, and exponent is 5. So negative 2 is a base and 5 is an exponent or power. Please pay attention that if base is negative, we have to use, or we must use, parentheses. Now, how can we read this? It will be negative 2 to the 5th power. Let's practice in reading and understanding. If we have example number 1, positive 3 times positive 3 times positive 3 times positive 3 times positive 3, we can show this as 3 times 3 times 3 times 3 times 3. Now, exponential form required to answer the questions. First, how many equivalent factors do you see? Let's count 1, 2, 3, 4, 5. Okay, so base is 3 and exponent is 5. And because base is positive 3 or just 3, we don't need to use parentheses. How to read this? Positive 3 to the 5th power. Example number 2. Negative 4 times negative 4 times negative 4 times negative 4 times negative 4. Again, how many equivalent factors do you see? 1, 2, 3, 4, 5. Base is negative 4 and exponent is 5. So we can show negative 4 and exponent is 5. And because base is negative, we must use parentheses. How to read this? Negative 4 to the 5th power. Next example. negative 1 times positive 3 times positive 3 times positive 3 times positive 3 times positive 3. Or it will be like negative 1 times 3 times 3 times 3 times 3 times 3. If you want to show shortcut exponential form, we have to answer the question, how many equivalent factors do you see? Equivalent, the same means the same. Let's count 1, 2, 3, 4, 5. Okay, so base is 3 and exponent is 5. But we had one more factor, negative 1, so we have to keep that one as it was. But sometimes you will see negative sign and then 3 to the 5th power. So this negative sign is not inside parentheses, so it's not part of the base. You have to pretend that you can see that 1. So while you are reading, it will be negative 1 times positive 3 to the 5th power. One more example. Negative 1 times negative 7 times negative 7 times negative 7 times negative 7 times negative 7. Again, how many equivalent factors do you see? 1, 2, 3, 4, 5. Okay, so base is negative 7 and exponent is 5. But we have one more factor, negative 1, so we have to keep. And sometimes you will see like this, negative sign outside of parentheses, and then negative 7 within parentheses, and exponent is 5. So this negative sign outside of parentheses, it's not a part of the base. Now how to read this? Negative 1 times negative 7 to the 5th power. Please pay attention. It's a tricky moment, but this is how it is. Next example. Positive 3 times positive 3 times x times x times x. Or it can be 3 times 3 times x times x times x. As you see now, that we can use numbers as a factors, or we can use variables as a factors. Now question is, how many equivalent factors do you see? 1, 2. We have 2 equivalent factors. 3 is a base and exponent is 2. And then x we can see as a factor 3 times. So base is x and exponent is 3. How to read this? Positive 3 square times x cube. Next example, we have negative 6 times y times y times y times y. Again, how many equivalent factors do you see? 1, 2, 3, 4. Okay, so base is y and exponent is 4. But negative 6 we have to keep as a factor. Now, negative 6 times y to the 4th power. Next example. Negative 1 times y times y times y times y. Question is, how many equivalent factors do you see? Let's count. 1, 2, 3, 4. So base is y and exponent is 4. And negative 1 we have to keep as a factor. Now, it's a tricky example because it can be shown as negative sign up front and then y to the fourth power. Now question is, how to read this? How to understand this? Negative sign is not inside of parentheses, so it's not part of the base. So we have to pretend that you can see that 1, even you don't. So it will be -1 times y to the fourth power. And one more example. -1 times parentheses y and -1 times parentheses y and -1. As you see, factors can be very simple or can be more complicated. In this case, we have two factors, y and -1. So base is y and -1, and exponent is 2. So we have to keep -1 times, and then it will be parentheses y and -1 squared, because base is y and -1. Here is tricky notation. So how can we understand this? This negative sign outside of parentheses. So it's not the part of the base, because it's not inside of parentheses. How to read this? -1 times y and -1 squared. Next example. +2/3 times +2/3 times +2/3. Question is, how many equivalent factors do you see? 1, 2, 3. So now base is 2/3. Base is a fraction and exponent is 3. How can we read this? 2/3 cube, or 2/3 to the third power. Next one, what we will have? -2/3 times -2/3 times -2/3. How many equivalent factors do you see? Let's count. 1, 2, 3. Okay, so base is -2/3 and exponent is 3. And because base is negative, we must use parentheses. How to read this? -2/3 cube. We continue practicing in reading and how to convert exponential form into factored form. Example number 1. We have +3 to the fifth power. That means that we have to use +3 as a factor 5 times. Next, we have +2 to the sixth power. So we have to use base +2 as a factor 6 times. Next, from the number 3, we have -5 to the fifth power. So we have to use -5 as a factor 5 times. Next, -7 to the sixth power. So we have to use -7 as a factor 6 times. And next would be, we have to use magic number 1. Now we can read this. -1 times +9 to the fifth power. If you don't have parentheses, then exponent affects only and only nearest number. In this case, exponent affects only and only 9. So it will be -1 times +9 times +9 times +9 times +9 times +9.